Now we're going to be looking at the graphs of sine, cosine and tangent. We'll do sine first. The sine graph goes between 1 and -1. So its highest value is 1, its lowest is -1. It starts at 0, goes through the origin. So 0, 0, up to 1, back down. That's at 180 degrees. At -1 at 270 degrees. And back to 0 at 360. Now this same graph, this 360 degrees, that repeats over and over again. So we're just going to continue that same pattern over and over again. And we can extend it over and over again. So this is 90 degrees, 180 degrees, 270, 360, and then it'll be 450, 540, and so on. We can extend it forever. And going backwards, we've got -90, -180, -270, -360, and again we can extend it in the negative direction, going on forever. And this same pattern just repeats over and over again. The cosine graph is very similar. It goes between 1 and -1 as well. But the cosine graph starts at 1. So it starts at 1, it then goes down through 90. It's at -1 at 180, and then back up at 270, and it's back at 1 at 360 degrees. And again, this 360 degrees repeats over and over again. So we'll just keep going with the same graph. And again, this is 0, 90, 180, 270, 360, 450, 540, and backwards, -90, -180, -270, and -360. So that is the cosine graph. The tan graph is different. So the tan graph doesn't have a maximum and minimum. It doesn't go between 1 and -1. And it's got asymptotes. So at 90 degrees. And this graph repeats every 180, not every 360. So every 180 degrees, there is an asymptote. So the graph goes through 0, 0 and up. It never reaches 90 degrees. It never crosses 90 degrees. And the same pattern repeats every 180. So again, 0, 90 is undefined, 180, 0, 270 is undefined, 360, 0, 450 is undefined, 540, 0. And that is our tangent graph. Here we have a question. Sketch y equals sine x for 0 to 360 degrees. So we've got 0, 90, 180, 270, 360. And we know the sine graph starts at 0, 0. It goes up to 91, back down 180, 0, at 270, -1, and back up to 360, 0. So that is our sine graph. Given that sine 60 is square root 3 over 2, so we're going to say sine 60, so that's about here, sine 60, might be too high, square root 3 over 2. Find another value of x for which sine x is square root 3 over 2. So we're going to use symmetry here, and the sine graph is symmetrical about 90 degrees. So this gap here between 0 and 60, where else is it root 3 over 2? It's root 3 over 2 here as well. And it's symmetrical, the same distance away from 90 on both sides. And we can say the 0 to 60 is the same as this gap here. And with sine, to find the second answer, we do 180 minus the first answer, just like we did with the sine rule. So to find the second answer, we're going to do 180 minus the first answer. So 180 take away 60 is 120 degrees. Part C, find two values of x for which sine x is negative square root 3 over 2. So what would that look like on the graph? So this peak here is going to be the same as this peak here, only it's negative. So let's do negative root 3 over 2. That's going to be down here, negative square root 3 over 2. So it's going to be here and here. So we were 60 away from the 0. So 60 away here. So 180 plus 60 is 240 degrees. And 360 take away 60 is 300 degrees. So it will be negative root 3 over 2 at 240 and 300. We can check our answer on the calculator. So if we put sine 240, we get negative root 3 over 2. Sine 300 will give us the same answer, whereas sine 60 and 120 will give us square root 3 over 2. Here's another question. If you can, pause the video and give it a go. If not, just keep watching. So sketch y equals cos x for 0 to 360. Our cos graph goes between 1 and negative 1. It starts at 1 and comes down through 90, 0, 180, negative 1, 270, 0, and 361. That's 0, 90, 180, 270, 360. Given that cos 45 is root 2 over 2. So cos 45 root 2 over 2. Find another value of x for which cos x equals root 2 over 2. So where else is it root 2 over 2? You have to go all the way over to this side over here to find somewhere else root 2 over 2. And again, we're going to use the symmetry of the graph. This time it's symmetrical about 180 degrees. And we can say this gap here between 0 and 45 is the same as this gap here between 360 and our second answer. When we have cos, we can get the second answer by doing 360 minus the first answer. So 360 minus 45 will be 315 degrees. Find two values of x for which cos x equals negative root 2 over 2. So 45 degrees away from 90 here. So this 45 on this side, 45 on the other side will take us down, and 45 from 270 will take us down to negative root 2 over 2. So this gap here will be the same as this one here, and the same on the other side. So 90 plus 45 be 135 degrees. And 270 minus 45 will be 225 degrees. And we can check on the calculator. Cos 135 is negative root 2 over 2. Cos 225, negative root 2 over 2. And one more. Again, if you can, pause the video, give it a go. So it's the tan graph. This time we've got, it repeats every 180 degrees. And we've got these asymptotes. So it goes up through 0, 0, through 180, 0, and through 360, 0, '90, 180, 270, 360. Given that tan 30 equals root 3 over 3, so let's just say it's here, root 3 over 3, 30. Find another value of x for which tan x equals root 3 over 3. So the tan graph just repeats every 180 degrees. So it's going to be 180 more than 30, which would be 210. So the tan graph is just going to repeat every 180 degrees. So we can keep adding on or taking away 180 to find another answer that's the same. Find two values of x for which tan x equals negative root 3 over 3. So again, this gap here, which was 30, will be the same as this gap here. So instead of 180 plus 30, 180 minus 30 is 150 degrees. And then that repeats every 180. So I can do 180 more than that. 150 plus 180 is 330 degrees. And I can do 180 less, I could do negative 30, or 180 more than this one, which would be 510. And we can just keep repeating by adding on another 180 degrees. So 150 works, and 330 will work. And I could also have taken 180 off, done negative 30, and that would have worked as well.